Hello, this is Mr. Tipton, and today we are back with volume. Finding the volume of prisms. Volume is the number of cubes in a three-dimensional figure. Area was the number of squares in a two-dimensional figure. Volume is three-dimensional, so it's how many cubes will fit into a 3D figure. Today we are only going to look at the volume of prisms. You can find the volume of other things, cylinders, cones, spheres. We're just going to look at prisms today. And our formula for the volume of prisms, V is equal to B, capital B, times HP. Capital B stands for the area of the base. When we did area of parallelograms, we used a lowercase b times h for base times height, and that found an area for us. But our area is going to change depending on what shape the base is. Alright, we'll always need the area of the base, but you just need to understand that lowercase b and capital B stand for different things. Here it stands for the area of the base. Now the HP, I want you to think of this as one number. Okay, HP stands for the height of the prism. Okay, there's not a separate amount for H and P. Just think of HP as one thing. Kind of like in our trapezoid formula, we had half the height times base 1 plus base 2. Base 1 and base 2 were each just one number. I want you to think of the same thing when you see HP. It's the height of the prism. When we're talking about three-dimensional figures, it's important to know that the bases of a three-dimensional figure are opposite, parallel, and congruent. Sometimes you're not sure, how do you know it's the base? Well, it's not always what's on the bottom. You can tell things are the bases when they are opposite, parallel, and congruent. And it's also important to know that the height of a prism connects the two bases. So, let's look at some examples and find the volume of prisms. We're going to start out with this rectangular prism, and we'll start out with our formula. Volume is equal to capital B, the area of the base, times the height of the prism. Now, what kind of prism is this? Well, it's a rectangular prism because the bases are rectangles. Because the base is a rectangle, to find the area of the base, we're going to use base times height times the height of the prism. Okay, I know there's a lot of letters here, but I want you to understand that this, rectangular base is this first part. Oops, rectangular base is what that's supposed to say. The part that's in parentheses is how we find the area of the rectangular base. This other part, the HP, is the height of the prism. Okay, let's go ahead this time and use the bottom. Even though a rectangular prism has three different sets of bases we can use, this time we'll just use the bottom as the base. Okay, the bottom of this figure and the top of the figure are opposite, they are parallel, and they are congruent. So they can be the base. The base of the base, the little b of the big B, is 12. And then the height of the base is 5. Okay, the rectangle on the bottom of this prism is 12 by 5. Now the height of the prism, actually let me outline the other base in green. Here are the two bases. They're opposite, they're parallel, they are congruent. The height of the prism, the HP, connects those two bases. And that is 6 inches. So basically, in this picture, I'm just multiplying the three numbers, 12 times 5 times 6. But it's important to show your work and to know why multiplying these three numbers gives us the volume. 12 times 5 is 60, and 60 times 6 gives us a volume of 360 cubic inches. When we have area, we have square inches. When we have volume, we have cubic inches. All right, let's look at another. Another rectangular prism. Got a longer, skinnier one this time. We still start with our formula. Volume is equal to area of the base times the height of the prism. And because it's rectangular, it doesn't matter which set of bases we use. There are 3 different sets of bases that are opposite, parallel, and congruent. That's what's nice about rectangular prisms. Actually, this time I think I'm going to use this side and its opposite for the bases. Okay? And here. These are our bases. They are opposite of each other, they are parallel, and they are congruent. They're the same size. And they are rectangles, so once again I'm going to use little base times height times the height of the prism. Okay, the base and height of the base is going to be 20 times 4, and the height of the prism connects those two bases. Okay, even though the height is going left and right this time, it's still the height because it connects the two bases. 20 times 4 is 80, times 7 is 560. Oh, pen's had enough. 560 cubic centimeters. If you have questions about the 3 different sets of bases that you can use because it's a rectangular prism, ask me about it. I'd be glad to show you. Let's move on now to triangular prisms. These are a little different, obviously, because they are triangular and not rectangular, but we're still going to use the same initial formula. Area of the base times the height of the prism. The difference here is that instead of using base times height for capital B, we're going to use half base times height, because the bases are triangles. The base is not a rectangle. Just because it's on the bottom, that doesn't matter. You have to use bases that are opposite, parallel, and congruent. The same on both ends. So in our triangle, I'll just stick with blue here. The base and height of the triangle, I'll write that down. The base and height of the triangle is going to be, I'm going to need another color, here by here, not the 5, because remember the base and height of a 2-dimensional figure have to make a right angle. So we've got half times 4 times 3 is the height of the triangle. And our height of the prism connects the bases. Again, the height of the prism, I know it's on the bottom, but that doesn't matter. It's connecting the two triangles. The height of the prism connects the bases. We are ready to multiply now. Half times 4. Half of 4 is 2. Times 3 is 6. And then 6 times 10. Pen does not like all the writing I've done. Is 60 cubic feet. Area of the base times the height of the prism. The base is a triangle, so we used half base times height times the height of the prism, and we just substituted in the numbers that we knew. Let's do another triangular prism. Same formula. Volume is equal to area of the base times the height of the prism. The base is a triangle, so we're going to use 1/2 base times height times the height of the prism. And let's find our parts of the triangle. The base and height of the triangle. Here's our triangle right here. Opposite, parallel, and congruent. Looks like our base is going to be 8 and our height is going to be 6. 6 and 8 make the right angle. 7 is the slant height. It does not make a right angle. And then our height of the prism connects the two triangles. So times 16. Half of 8 is 4. 4 times 6 is 24. Times 16 is 384. Come on. 384 cubic meters. Volume of prisms has a really simple formula, but it can get confusing when the bases start changing shapes. We are only going to deal with rectangular and triangular prisms right now, so we need to make sure we remember how to do the area of rectangles and triangles. Other than that, make sure we're identifying the correct bases. They are opposite and parallel and congruent. And we remember that the height of the prism connects the two bases. If you have questions about anything we've done, write them down. We'll talk about them in class. See you soon.